Hello friends, welcome to Risingpearl.com. Today we are starting a brand new series 8, where we are going to be learning Arithmetic Progression. This is our episode number 1. Now friends, Arithmetic Progression is not something that we have seen earlier. It is not like a triangle where we have had some idea what it is and then we are learning or expanding our knowledge of the basic thing. This is a brand new topic for us and we will take some time to understand step by step what is meant by arithmetic progression, and this is our first webisode. So this is an introductory webisode on arithmetic progressions. Now let's take a look at this set of numbers: 8, 11, 14, 17, 20, 23. Let's write a few more sets of numbers: 10, 5, 0, minus 5, minus 10, 10, 30, 50, 70, 90, 110, 3, 3, 3, 3, 3, 3, 3, minus 4.5, minus 7, minus 9.5, minus 12. Now each one of them, so this is a first set of numbers, this is a second set of numbers, third set of numbers, fourth set of numbers, and fifth set of numbers. On the surface, if you look at each one of them, so this is a first set of numbers, this is a second set of numbers, this is a third set of numbers, this is a fourth set of numbers, and this is a fifth set of numbers. On the surface, each of these sets of numbers, they look totally random. It doesn't look like there is any commonality between them. But there is something which is very unique to each one of these sets of numbers. And that uniqueness we can see in each of these sets. So let's look into it and find out what is something which is special in each of these sets of numbers. Now, one thing before we move on, I would want to just let you know that, whether we call it a sets of numbers, we call it a collection of numbers, or we call it series of numbers. So going forward, we can use any of these words, but because this is arithmetic progression, you will see that we will probably mostly be looking to use this term. And again, they all mean the same. Basically what we are referring to is that we are saying this collection of numbers or this series of numbers. Similarly, this sets of numbers or this series of numbers. They all mean the same exactly. It does not matter. So just going forward, we are going to be using the word series to refer to the collection of numbers. So let's take a look at the first set of numbers, or first I should say series of numbers, and see what is going on. Now 8, 11, 14, 17, 20 and 23. Let's take a look at this number, which is a second number. So the second number, and this is a short form for the symbol for number. So the second number is 11. And our first number is 8. As we can see, it is 8. Let's do one thing. Let us subtract the first number from the second number. So if we do that, 11 minus 8 is 3. Why did we do it? Just give me one moment and stay with me on this. Let's now take a look at our third number. So the third number is equal to 14. Let's subtract the second number from third number. Now second number obviously is still 11, that has not changed. This is a second number. Let's subtract 11 from 14. 14 minus 11 is 3. Now let's move on to our fourth number. So our fourth number is equal to 17. Let's subtract the third number from fourth number. Third number is 14. So if we subtract this, 17 minus 14 is 3. So let's do it for the rest of these two numbers. So fourth, now this is a fifth number. So our fifth number is equal to 20. And our fourth number is equal to 17. So if we do the subtraction, 20 minus 17 is 3. And finally our sixth number is equal to 23. And as you can see, so our fifth number is equal to 20. So now we are at our sixth number. Fifth is 20 and this is 23. So if we subtract that, we will see 23 minus 20 is 3. So what is really going on with this series of numbers? So for this series of numbers, what is unique is that if we take any of these numbers and if we subtract the immediate previous number from it, we get 3. So when we took the second number, we subtracted the first number, we got 3. We took the third number, subtracted second number from it, we got 3. We took the fourth number, subtracted the third number, we got 3. That is, whenever we take any number, and obviously by number I am talking about starting from second number, because if you take the first number and you subtract the 0th number, but there is nothing called 0th number, so we have to start from the second number and subtract the first from it. We take the third number, subtract the second number from it, so on and so forth. So if you take any number in the series starting from the second number onward, if we subtract the immediate previous number, we get always 3. So this is kind of really strange about this particular series of numbers. Let's take a look at our next example now. So now this series of numbers, so our last set or series had actually 6 numbers. So here we will start from a second number. So we have 1, 2, 3, 4, 5 numbers in this. So we start with a second number. So let's say our second number is actually 5. And we are going to our first number. So our first number is 10. So we will do the same thing. We will subtract the first number from second number. So let's see what happens. 5 minus 10 is minus 5. This is interesting. Let's take the third number. So we take our third number, and third number is 0, and we take a second number now and we subtract the second number from the third number. So if we do that, we get 0 minus 5 is minus 5. Let's take a fourth number. Fourth number is equal to minus 5. And our third number is equal to 0. So if we subtract 0 from minus 5, that is minus 5 minus 0 is again minus 5. And finally our fifth number, let's take a look at our fifth number. Our fifth number is minus 10. If we subtract the fourth number from it, fourth number is minus 5. So if we subtract this, so then minus will become actually plus. So minus 10 plus 5, because what will happen is you will have minus 10 minus 5. So this will be equal to minus 10 plus 5, which will be equal to minus 5. So this is again minus 5. Minus 5. So interestingly, for this series of numbers, what we see is that whenever we take any number starting from the second number onward, and if we subtract the previous number from it, we always get minus 5. So I think, friends, you are beginning to hopefully see what is going on in each of these sets of numbers. Let's take a look at the third set of numbers, or the third series. So we will begin from the second number and we will take a look at each one of them. So our second number, and as you can see that it's getting a little confusing, because we are saying second number is the number 30, third number is the number 50, we are going to call each one of them, we are going to use the word term, T-E-R-M. So each of the numbers will be a term. So we will say this is the second term. So it will take a little bit getting used to it, but let's start doing this. So our second term is 30. Our first number, I'm still using the word number, the first term is 10. So if we subtract the first term from second, 30 minus 10 is 20. Let's take a look at the third term. So the third term is 50. And let's subtract the second term from the third term. So we get it is 30. So if we subtract, we will get 50 minus 30, 20. So similarly, how about we take this one? So this will be first, second, third, fourth, fifth term. If we take our fifth term, and fifth term is 90, and we subtract the fourth term from it, which is immediately before the fifth term. So the fourth term is 70. So if we subtract 70 from 90, we again get 20. So in this case, in this collection of numbers, this value 20 is always the difference between the current term and its immediate previous term. So friends, in other words, if I take any of this number, so for example, let's take this number or this term. If I take any of the terms and if I add 20 to it, then I can get the next term. So for example, so 1, 2, 3, 4. So if I take the fourth term, and if I add this 20, then the fourth term is 70. If I add 20, then I get the next term, which is 90. So this is really interesting. So what is really happening is that if we take any of these terms, so this collection, this series has 1, 2, 3, 4, 5, 6 terms, a total of 6 terms. If I take any of the 6 terms, so if I take the first term and add 20, I get the second term. If I take the second term and add 20, I get the third term. If I take the third term 50 and add 20, I get the fourth term. So if I take the fifth term 90 and add 20, I get the 110. So this number 20, which is a fixed number for this series, this number 20 is called common difference. Let's see if we can write it here. This is called common difference because this number is common for the entire series. And the reason it is called common difference is that if you take any number, like the way we talked about, if you take any term and if you subtract the previous term, that is, if you take the difference between any term and if you subtract the previous term from it, you will get 20. And whether we take this term and subtract 10, we get 20. If we take this term and subtract the previous term, we get 20. If we take this term and subtract previous term, we get 20. Similarly, if we take this term and subtract the previous term, we get 20. If we take this term and subtract the previous term, we get 20. So the 20 is really the common difference for this particular series. So it is very important to keep this in mind. So if you were to quickly go back and take a look at what happened in the first example. So now if you go back and take a look, so first example had 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 terms. So there were 6 terms in the first example. And the common difference, that is if we randomly take any one of the term and subtract the previous term from it, which is 14. 17 minus 14 is 3. Right? Similarly, the difference between 14 and 11 is 3. So 20 and 17 is 3. 23 and 20, the difference is 3. So 3 is the common difference. So the common difference in our first collection or first series of numbers was 3. So similarly, if we take a look at our second series, in this series we had 1, 2, 3, 4, 5 terms. So there were total 5 terms, not 6, 5 terms. And the common difference in this case, common difference in this particular case, I think I misspelled it totally, is minus 5. So the common difference actually is a negative number, but it is fixed. It is same throughout the series. The common difference is not changing. Very, very important to note that. So the difference between any of the number and its previous number remains same. So for this series, common difference is minus 5. For the previous one, it was 3. And the current one that we saw, the common difference is 20. So also, what it is important to kind of understand is that, like we just talked about, if you take any of the number and add the common difference, it gives you the next term. So let's take a look at our fourth set of numbers. This is interesting. They're all 3. So first of all, 1, 2, 3, 4, 5, 6. There are 6 terms. How many terms in this collection? There are 6 terms. So let's take a look at our second term. Our second term, which is this number, that is 3. If we take a look at our first term, and in this case it's 3 again. So if we subtract the first from the second, 3 minus 3 is 0. So if we take a look at our third term, this is all confusing. Third term is 3. So third term, 3. And if we subtract the second term, which is again 3, from the third term, 3 minus 3 is again 0. So similarly, what we are noticing is that if you take a look at any of these terms and you subtract the previous term from it, you will get 0. So in this particular series, the common difference is actually 0. And I want to highlight this important point to you, that this is the fourth example. So in the first and the third, the common difference was a positive number. In the second example, it was minus 5. And in this fourth example, it is 0. So it is important to note that common difference can be any number. It can be even a decimal. It can be even 0. It can be even negative. It does not matter what it is, but what you are looking for is that in the series, common difference has to be the same, right? So meaning that if I had a next term on this, let's say just for discussion's sake, let's say 2, then this will not be consistent, because then 2 minus 3 will be minus 1. And 3 minus 3 is 0. So that cannot be. So this kind of sets of numbers where you take any term and you subtract previous term from it and you get the same value for each and every term, this kind of series of numbers is called arithmetic progression. So let's take a look at a fourth example that we have not taken a look at it just yet. So we have 1, 2, 3, 4 terms. So in this particular series there are only 4 terms. So this is the first term, this is the second term. So we will start with the second term. So our second term is equal to minus 7, and our first term is equal to minus 4.5. So let's do what we have been doing. Let's subtract the first from the second. So the minus will become plus here. So minus 7 plus 4.5. So this will be minus 2.5. Right? Because minus 7 plus 4.5. So 0.5. Yeah, it will be minus 2.5. Let's take our third term now. The third term is minus 9.5. Minus 9.5, and our second term is minus 7. Minus 7. So if we subtract second term from the third term, so minus 9.5 plus 7 will be minus 2.5. So in this particular set or collection of numbers, which is the last example, we see that the common difference is equal to minus 2.5. Minus 2.5. This is the common difference. Or in other words, if we randomly take any term, let's say we take this term, and if we add common difference, then we will get the next term. So for example, this is the third term, right? So our third term plus common difference, in short let's write it actually CD, is going to be, so the third term is minus 9.5 plus common difference is minus 2.5. So minus 9.5 minus 2.5 will be minus 12. So if we take the third term, add common difference, we get our fourth term. So which makes sense, right? Because if you take any of the term and if you subtract the previous, you get, the common difference, right? Which is the same as if you take this term and add common difference, you will get the next term, right? So finally, friends, I want to actually sum up a few things here for us. So looking back through all this collection of numbers, all these series of numbers, the first one, the second one, the third one, the fourth one, and the fifth one, while on the surface they all look like random sets of numbers, random series of numbers, but what we did note for all of them was the difference between one term and its previous term always has been same. So now these differences will be different from different series, but within a series, if you take any term and if you subtract the previous term, that value has been constant. The common difference value has been constant. Like I said, in the first example, it was plus 3. In the second example, it was minus 5, the common difference that is. In the third example, it was plus 20. In the fourth example, it was 0. And in the fifth example, it was minus 2.5. It does not matter whether it is a positive number, it is a negative number, that is the common difference, or even if it is a 0. as long as it is same throughout the series. That is what is very important. And each of these sets of numbers or collection of numbers, we call them arithmetic progression, or AP for short. So similarly, let's now quickly recap. So we have these sets of numbers, series of numbers. Now each number in the list is called a term. We talked about that. Each number, so this is a first term, this is the second term. So in this case, this one will be 1, 2, 3, fourth term. Here this one will be similarly first, second, third, fourth, fifth term. Here this is the second term, and here this will be similarly the fourth term. 1, 2, 3, 4, fourth term. So each number in the list or in the series or in the collection is called a term. Then we looked at arithmetic progression, because this is about arithmetic progression. So arithmetic progression is defined as a list or a series of numbers in which each term is obtained by adding a fixed number to the last or the preceding term except the first term. And that is what we talked about, right? Because if the common difference, and let's see, the last and final point will be the fixed number is called the common difference. And common difference is usually represented as D, because CD is just too long, so we just remove the C. So the common difference is represented as D. So in this first example, our common difference was 3. So if I take any term, so for example, if I take this term and add common difference, then I get the next term, right? 17. So if I take 17 and if I add the common difference, I get the next term. So this kind of list or set or collection or series of numbers where each term is obtained by adding a fixed number to the last term is called arithmetic progression, or AP in short. So friends, in this series we are going to learn a lot more about what kind of properties do these arithmetic progression series they have.